how many functions are there from the set 1, 2, 3, 4 all the way to n, where n is a positive integer, to the set 0, 1 that are 1 to 1. So first let's take the case 1 when n is equal to 1, right? So we're talking about essentially when 1 is the n value, right? There's only one element in the set, and we need to map it to the given set 0, 1 that never changes. The possibility of the 1 to 1 is going to be 1, 0, or, that's a different function, 1, 1. Right? How do we know that these are different functions? So we're assigning 0 to 1 or 1 to 1. We cannot assign both because otherwise it's not going to be a function. Right? You cannot have a function with the same x value that has different y values, right? So no two distinct y values may have the same x value. Otherwise it's not a function, right? So these are two different functions. So as a result, there are two functions in this case that are possible. So now the second case is when n is equal to 2. So that means we will have a larger set. N is equal to 2. The set is larger. It has 1 and 2 now. The n value takes the value of 2. But the set that we're going to map it to doesn't change, right? It's 1, 0, 1. So in this case, what are the possibilities of the 1 to 1? We can have 1, 0, right? And then 2, 1. Or, again, we can have 1, 1, or 2, 0. Right? And 1 to 1 requires that no two distinct x values produce the same y value, right? So in this case, there are no repetitive y values, so that's one function, and there are no repetitive y values for two distinct x values, right? So 0, 1 are distinct, right? So there are two different functions, there are no other functions possible. So again, there are two functions in this case. Now let's take n greater than or equal to 3. Now this is a problem, because if you have, for example, 1, 2, 3, etc., etc., and you're going to try to map it to 0 and 1, the given set here, suppose that you assign 1, 0, and then you assign 2, 1. But what are you going to do when n is equal to 3, for example, at least the value of 3? 3 will have to be mapped to either 0 or 1. So if it's mapped to 0, that's a problem. It's not going to be a one-to-one function, right? Because the y value will repeat, right? It will be 0 just like it was for the 1. And that's not possible. It is a function, but it's not a one-to-one function, right? So this is not going to work. 0 functions. So when n is equal to 1, two functions are possible. When n is equal to 2, two functions are possible. When n is greater than or equal to 3, you will have more members here that need to be mapped to only two members here, two elements, right? So one of these elements, at least one of these elements, will have to be repeated when n is greater than or equal to 3, which is going to create a problem and not going to yield you a one-to-one function, right? So 0 functions. So now part B says how many functions are there, and notice it doesn't say one-to-one function, it just says generally how many functions that assign 0 to both 1 and n, right? So here we have to think again of cases. Let's take the case when n is equal to 1. Again, you're going to take the primitive case when there's one element and you're going to map it to 0, 1, right? So the only possibility is that we have 1, 0, right? Because there's only one element available to pair up with the 0, because the constraint is that we have to assign 0 to both 1 and n. 1 here is both 1 and n, right? And we can only assign 0 to it. We can't assign 1, right? So that's only one function possible. Now the second case is when n is equal to 2. So when n is equal to 2, we're going to have 1, 2 paired to 0, 1. The possibilities is that you're going to have 1, 0, 2, 0. Right? 1, 0, 2, 0. Because 0 must be assigned to both 1 and 2. Right? So both 1 receive a 0 and 2 receive a 0. 2 in this case is the n value. Right? So this satisfies the condition. So there's only one way of doing it, so there's one function. Okay, so now when n is equal to 3, this case, again, here we're going to expand. We're going to make the set larger, and then the same number of elements, 0 and 1. So what are the possibilities there? We're going to have 1, 0, 2, 1, 3, 0. Or we can have 1, 0, 2, 0, 3, 0. Right? Because it doesn't say that you can't assign 0 to the middle element here, which is not 1 or n. Right? It doesn't say that in the constraint. It just says that 1 and n must be assigned a 0, which we did. Right? 1, 0 and n value is 3, 0. N value is 3 here, right? So it receives 0. But 2 can receive 1 or 0, right? Because 2 can have a 0 or 1. Right? So there are two functions possible in this case. And now when n is equal to 4, we're just trying to see if there's a pattern here, right? So when n is equal to 4, we're going to have 1, 2, 3, and 4 mapped to any one of these 0 and 1. So the possibilities here are going to be 1, 0, 2, 0, 3, 0, 4, 0. Right? It doesn't say that 4 cannot be assigned as, it doesn't say that 2 or 3, the middle guys, not 1 or n, doesn't say that it cannot be assigned as 0, right? So 1 and 0 and 4 and 0 are locked in. So what are the possibilities for these two guys? These two guys can be also 2, 1, 3, 0, that's the combination. It can be 2, 0, 3, 1, for example. Or it can also be 2, 1, 3, 1. Both of them receive a 1, right? So altogether, how many is that? 1, 2, 3, 4. 4 different functions, right? So 4 functions possible. So now, what is going to be the pattern here that you see? Let's see if there's a relationship between the numbers. So when n is 2, there's one function. When n is 3, there's 2 functions. When n is 4, there's 4 functions. So I'm thinking that it's going to be some kind of a power involved, right? So let's take the 2. If we take it, so notice that 1 can be expressed as 2, for example, to the 0th power, right? That's 1. 2 to the first power is 2. 2 to the second power is exactly 4. Right? So what is the relationship between this power and the n value? Notice that there's a 0 that's exactly 2 less than the 2. 1 is exactly 2 less than the 3, and 2 is exactly 2 less than the 4. Right? So you will have to subtract from the n value twice, like that. So 2n minus 2, 2 to the power n minus 2, functions for n greater than or equal to 2. Okay, so that's going to be the answer to part B. Now the last part is very interesting. It asks that we assign 1 to exactly one of the positive integers less than n. So we're going to take it case by case. When n is equal to 1, we're going to map only one element to the given set. Okay, so in this case, we need to find one of the positive integers less than n. N is the one value, and less than that there's nothing else, right? That's the only element. So if we can't map anything less than 1, there's no function available, right? So the answer here is no function, 0 functions, right? None. When n is equal to 2, the set is larger, so we have 1, 2 now, and we're going to map it to 0, 1. So the possibilities for here, so it says assign 1 to exactly one of the positive integers less than n, right? So we have to pair 1 with a 1 and 2 with a 0. But it doesn't say that you can't pair 2 with a 1, right? So it can also be 1, 1, 2, 1, right? So there are 2 functions possible. Okay, so 2 functions. Now when n is equal to 3, I'm going to have a larger set, 1, 2, 3. I'm going to try to map it to 0, 1. Right, so here we're going to have what possibilities? Right, so we have to have what? We have to have less than n is going to be 2 or 1, right? So we can have 1, 1. Then we can have 2, 0, 3, 0. Right, and then we can have 1, 0, 2, 1, 3, 0. Right? So one must be assigned to exactly one of the positive integers, right? So exactly one of these two guys must receive a 1 only, right? And what else can we have? We can have, and that's it, right? That's it. But the only thing is, it doesn't say that 3, right, the n value is not allowed to have 1. It doesn't say that, right? So we can have a 1 there and we can have a 1 there, right? So as a result, there are 4 functions, 2, and also the 2 functions where n is paired with 1, right? So that's 4 functions. And finally, when n is equal to 4, that's going to be needed to see if there's a pattern, right? So we're going to have 1, 2, 3, and 4. And I'm going to map it to the given set 0, 1. So what are the possibilities? Let's pair 1 with a 1 first. The others must be 0, except the very last one, right? So then we're going to have 1, 0. 2 will be paired with 1, because only 1 must be paired with 1 less than 4 in this case, right? So out of the 3 guys, 1, 2, and 3, only one of them will be assigned 1. In each case, in each separate case, right? So 3, 0, 4, 0, and then finally 1, 0, 2, 0, 3 receives a 1 finally, right? And then 4 receives a 0. But again, it doesn't say that 4 is not allowed to be paired with 1, right? It just says positive integers less than n must be paired with 1 in each case, right? Only. Right? So 4 can be paired with 1. So what I'm saying is there are 3 functions, but there's actually 6 functions because 4 can be paired with 1 in each case as well. Right? So there are 6 functions in total. 6 functions. So now let's see what the relationship is between the numbers here. So when n is equal to 1, there's 0, right? So n is 1, you get 0 functions, right? So I'm already thinking n minus 1. But now when n is equal to 2, the answer you get is 2. Substituting 2 inside the n here, you get 2 minus 1, that's equal to 1. But we need a 2, right? So we need to multiply this. We can multiply this by 2. And now let's check if this formula 2 times n minus 1 works for these 2 other cases that we checked. So when n is equal to 3, you get 4. So check 3. 3 minus 1 is 2. 2 times 2, 4. Bingo, it works. Now let's check the last one. When n is equal to 4, you get 6 functions. 4 minus 1 is 3. 3 times 2, 6. Bingo, so it works. So that's the answer. 2 times n minus 1, 4. So functions for all n. for all n greater than or equal to 1. Right? Thank you so much for watching this video. I hope this was helpful. See you in the next video.